all out right now. All right, so let's take a look. So this is going to be my chapter 5 unit review. This is the short answer. This is the one that we're going to be taking first. Now, like every time I tell you guys this, whenever we're taking these tests, the test is almost exactly the same as the review. So, I really need you guys following along, and if you guys go over this a bunch of times, it will help out. Okay, so let's take a look at what we got here. So find the exact value of this. Now, this same problem, we've only have so many different combinations that we could use. We've done this problem so many times. So on this one right here, this one says the sum and difference. So that's going to be the plus or minus. So now I'm going to go to my reference sheet. Huh?
You have to read those? Okay.
That's usually why.
I never read those.
Okay. So sum and difference. So on your reference sheet right here, it's going to be on here. Sum and difference. Sum and difference identities. Now, if I'm looking for a cosine, so I'm going to be using a cosine. But first, let's find out where that's going to be. So if I do my math, a lot of people don't like radians, so let's turn this into degrees. Negative pi over 12 times, and then do my math. No, I do not. I have to make more copies. I'll get some more. Okay, so what do we come up with? Negative 15? Okay, very good. So equals negative 15 degrees. All right, so negative 15 degrees is going to help me out here. So to get negative 15, I'm going to use my unit circle using addition or subtraction. So easiest ones.
30 minus 45.
Yeah, very good. So 30 minus 45 is going to give me a negative 15 here. So I'm looking for the cosine. So it's going to be the cosine of 30 minus 45. And that's going to give me my negative 15 degrees that I'm looking for here. Now, in my formula, this is my A and this is my B. Let's see, cosine minus right here. So this one uses S and T's for my variable. So cosine of S and T. So it's cosine S, cosine T, plus, remember the signs are opposite, sine S, sine T. So for what I'm writing for this is going to be cosine 30 times cosine 45 plus sine 30 times sine 45, multiplication there. All right, from my unit circle, cosine of 30 is going to give me rad 3 over 2, very good. Cosine 45, rad 2 over 2, okay, plus sine 30, 1/2, sine 45, right there. Okay, anyone questions so far? Okay, multiply fractions straight across. So this is going to give me a rad 6 over 4 plus rad 2 over 4, which with the common denominator is going to combine to be rad 6 plus rad 2 all over 4. Now, if you chose different numbers, not the 30 and 45, you could still get a correct answer out of it. So what would another acceptable answer be? Rad 2 plus rad 6 all over 4, right? Yes? Okay, so that's equivalent to this answer right here. Same thing. All right, questions there? Easy enough? Okay.
It says sum and difference, so now we have to do a sum or no?
No. Sum and difference. Identify the sum and difference identities. Okay, so we use this one right here. If you could have used an addition, just adding a negative number, but I don't like using negatives from my unit circle. I really don't. So use a coterminal or use something else, but this is going to give me my answer. All right, so now that just says which ways we could do it. We've done this before using half angle identities. We've done this before using half angle identities also. Okay, so this would have been, to get this, it would have been negative 30 over 2, right? Yes? That would have been a half angle identity to get to this. So there's more than one way. There's a bunch of different ways. That's why I underlined this right here. This is using sum and difference. And that's why I pointed out for my reference sheet the sum and difference, which ones you're using. These two right here. All right, so let's take a look at the next one down here. All right, given. That's important. So I have an angle A and an angle B. So given my angle A, so from A, I have my Y is 3. My R is, and my X,
4.
it's going to be 4. That's a Pythagorean triple, right? So it's going to be, and if it doesn't come out like that, I would just use Pythagorean theorem, wouldn't I? Pythagorean theorem to find it. Now, X, it says right here, okay, A is in quadrant 1. B is in quadrant 3. So this one is going to be a positive 4, right? Now, let's take a look. You know what? Just for the sake of my video, I am going to do this anyway. X squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. Subtract 9. X squared is 16. X equals plus or minus square root of 16. So X equals plus or minus 4. And then we said it's in quadrant 1, so therefore it had to be positive 4 there. All right, so there's my A. Now let's do the same thing for the B. So given B, my Y value is negative 12. My R value is, and my X value will be negative 5. Again, another Pythagorean triple. So I'm going to go ahead again. I'll do this one because I don't have the X. So if I were to do this, it would be, looking for the X again. So it would be plus negative 12 squared equals 13 squared. So that's going to be X squared plus 144 equals 169. Subtract 144 from both sides, so it's X squared is 25. X equals plus or minus square root of 25. X is plus or minus 5. And we said because this is in quadrant 3, X had to be negative right there. So it's not always going to come out to be Pythagorean triple, but yes, it's good to know those. We've done them a whole bunch of times, so you can see those. Save you a whole bunch of work. But yes, it's good also knowing the method for this if it's not. Cosine of A plus B. This one is a sum identity, so it's going to be the cosine right here. So it's cosine S plus T is cosine S, cosine T minus sine S, sine T. So let's take a look. Cosine S, cosine T minus sine S, sine T. Okay, plug those in. So cosine from S, so this is going to be in my thing, S and T, so it's going to be this one. So from my formula, I'm changing it. Huh?
Can you go back to the formula?
Right here. They're using S and T as their variables. So it's kind of like what we had before. Ours was A and B.
Where's the one where we switch it?
So.
Oh, never mind. It's
plus,
the one up above it.
Yeah. Right here?
First time.
Okay, yeah.
I was trying to...
Alright, so now, let's see. Cosine. So this is my S. So the A is my S. So it's going to be the cosine of my S thing again. Cosine of s
Cosine of this.
is going to be 4 over 5. Cosine of t, in this case, it's cosine of b, right? It's going to be negative 5 over 13 minus sine of s, which is going to be my a value here. So it's the sine of this one's going to be 3 over 5. Sine of t, negative 12 over 13. Negative 20 over 65 minus, it's going to be minus, and then I have a negative over here too, right? So it's negative 36 over 65. Now with the minus and a negative together, it's going to give me a plus, right?
Mm-hmm.
Okay, so this is going to be negative 20 over 65 plus 36 over 65, which is going to give me a grand total of over 65. Now, whenever you're doing these problems here, please show all your work. If you want to get credit for it, you have to get all the work here. You can't just, throw in an answer. Show your steps, especially if you get the answer wrong. I can give you points for your work. Make sense? Okay, set up, show everything you got. So, number 3. Now, this is everyone's favorite from 5.2.
Oh my god, I'm gonna kill you.
So, now, cosecant is the reciprocal of what? Sine, right? So, if I'm going to translate this into algebra, I would rewrite this as 1 over y times secant
1 over x.
all over cotangent, which is
X over y.
x over y. Now, if I were to put these together here, on top, I get what?
Y
Over
X.
x, y.
I get 1 over
X,
xy
Y.
or yx, right? Divided by,
X over y.
and we don't like fractions over fractions, do we?
No.
You have to multiply by the,
Reciprocal.
very good, 1 over xy times, the reciprocal of the bottom here is going to be
Y over
y over
X.
x.
So the y's cancel out.
The y's will cancel out, so I'm left with
1 over x squared.
1 over x squared. Now, as a final answer, let's translate this back.
Wait.
Secant squared.
Yes. What happened?
Okay, never mind.
Okay, right here, because these canceled.
Yeah, I get that now.
That one and that one cancel. So we get x times x, x squared. And then if I translate this back into trig, 1 over x is secant, but 1 over x squared is
Secant squared.
secant squared. And
It's gonna be theta.
theta. My variable is theta.
I like these. honestly. That's it.
Yes. So on the test, you're not going to have ridiculousness. I don't like throwing ridiculous problems in there.
Thank you.
Okay. So let's take a look at. I always try to get the homework to be harder than the test. So you should be like, test is easier. Should anyway. All right. So let's take a look at this, and we're going to translate this. Now, this is going to turn into, right here, this first part is going to turn into what?
1 over y over x.
Y over x, right? But it's y squared over,
X squared.
you guys okay with that? Plus, cotangent is
X over y.
x over y times tangent, which is,
Y over x.
now, let's start over here on the left. Right here, I don't like fractions over fractions, so I'd multiply by the reciprocal, right?
Yes.
So isn't this going to be 1 times the reciprocal, which is?
X
Squared over y squared.
Very good. And then put a plus sign over here. Now over here, what's going to happen to my x's?
Turn into 1.
It's going to cancel. What's going to happen to the y's? cancel, right? Because I have on top and bottom. What happens if I cancel everything?
It's
There's a
1.
one.
I get 1. I get 1 here. So this is going to be
Cotangent squared plus
x squared over y squared plus 1. Now,
Wait,
yes.
why did you get rid of the other one?
What other one?
multiplying.
What's
Oh,
1
never
times
mind
this?
that.
Okay, so this will get you 4 out of the 5 points. This will get you 4 out of the 5 points. Okay, if you were to write cotangent squared plus 1, that's going to give you the 5 points. Now, if you want the last point off of this, you guys have to identify what this is. So I'm going to go over here, I'm going to make my identities. So I know my identity is x squared plus y squared equals 1, right?
Yeah.
Okay, so if I wanted to match this, what would I do to this right here to match this? Divide everything by y squared. Y squared's on the bottom, right? Because I'm trying to actually make it into this. Divide everything by y squared. So it's going to be x squared over y squared is right here. Plus, what is y squared over y squared?
1.
1 equals, what's 1 over y squared? Just like that, right? You'll see it here in a second. So now, does this right here match this?
Yes.
It does, right? This matches this side right here.
So you could just leave it as 1 over y squared.
So to get your last point off of this one, you would actually look at it, change it to 1 over y squared, because this is substitution. So
And you would still leave the plus 1 or just all
Nope.
of that equals?
because all of this equals that. And I have all of that right here, don't I?
Mm-hmm. And then do we need to turn it back into
So it'd be cosecant squared.
Yes. So this turns into, let's translate it back into trig. It's going to be CSC squared. Do I have x on this case?
what if someone were to put 1 over sine squared?
1 over sine squared. I guess I could take that. It does the same thing. I could see that one there. So yeah, I could do this one. But if you can get it to here, it's 4 out of 5. But you have to verify the identity from right here. It's kind of like if you were to, so I'll go off on a different problem here. So if I were to go and I had 1 minus y squared as my answer. 1 minus y squared as my answer, that turns into what?
X squared.
That is x squared, isn't it?
Yes.
Okay, that is going to be x squared for this. It's the same thing if I had 1 minus x squared would be y squared. Does that make sense? So if you could do this part here, you get 4 out of 5. To get your last point, you have to use the identity on that. Are we okay? Questions? Hopefully I didn't freak you guys all out, because it only took me like 15 minutes to do this.
Well, I know I'll have at least one of my advantages.
Alright.